My name is Austin Amato. I'm the lead developer of the Medusa PCM integrated heat pump. You may have also seen it referred to as the Nile Pyroclast. I work with HTEC package systems and controls, and I'm here to tell you a little bit about HTEC and introduce you to some other electric solutions that we're bringing to market. I've been a participant on these calls now for a couple of years, been listening and innovating, and I'm excited to have this opportunity to talk at an all stakeholders meeting. So thank you for having me. The agenda for today is just to, like I said, introduce you to HTEC and tell you a little bit of what we've been up to. So HTEC Package Systems and Controls is the culmination of 58 years of HVAC and plumbing experience. While we've been designing skid packages for decades, we decided to start building and fabricating them ourselves about 10 years ago. We've built skids of all different sorts of sizes and types, from hydronic heating to domestic water industrial process into gray water reclamation, stormwater reclamation, you name it. So through the experience that we gained designing all of these different skids, building them ourselves, the decision was made about 3.5 years ago to get into the advanced water heating sector, and that's where our heat pump water heating efforts, R&D efforts began. The Medusa PCM integrated heat pump, you may have seen it on the showroom floor in Orlando at AHR. We did place as a finalist for the Innovation Awards, but we lost out to a residential circulating pump. Funny how that happens. But nonetheless, what this heat pump accomplishes is three main things. We're able to reduce the install time associated with a central heat pump water heating system, reduce the footprint necessary for these systems, and reduce complexity. It's been a big pain point that you guys have all been talking about for years, is the lack of skilled labor out in the field, the mistakes that come with improper installs, resulting in giving the technology just a black eye across the board, even though the heat pumps work just fine. But when taking a look at everybody that was out there and what they were doing with storage tanks that were designed to work with gas-fired water heaters, trying to force them to stratify, we had explored various options and ways of how we could store our thermal energy different. And we arrived at phase change materials as being the way of the future. These are available for order. We have the first 9 in production right now. They're going to be leaving out the door here in June. So stay tuned. You'll see some more of those pictures and posts, etc., come out about how the first few installs are going to be going this year. The last thing I'd like to mention about this before I move on is, like I said before, this is done through a strategic partnership with Nile Water Heating Systems. So you will see this being brought to market by both HTEC and Nile Water Heating Systems. In Northern California, it will be recognized under the Medusa branding. In the rest of the US and Canada, you'll see it as the Nile Pyroclast. And so what it is we have a Nile C90 air source unit mounted on top of 5 PCM thermal modules. Each module has the equivalent capacity of 75 gallons worth of stored hot water. So across the 5, we have 375 gallons worth of equivalent storage, but the storage is in phase change materials. The phase change material that we've landed on is a non-toxic, non-flammable, food-grade material. It's an inorganic PCM hydrated salt sodium acetate tetrahydrate. It has a melting point of 136 degrees Fahrenheit, making it perfectly suitable for domestic water applications where 120 to 125 degree water is delivered at the tap. The one application I would not suggest this product for is a specific like lab situation or kitchen where 140 degree water is required at the fixture. The melting point is 136, and while we can take the material above 136 and dump some more sensible heat into it, the vast majority of the time, the water leaving this unit is going to be 136. So I just want to throw that out there. While it is, the intention was to build a unit that addressed all of these market barriers, that's one that I would just not suggest it for. So within the thermal energy storage component of it, we have a control panel, a power distribution panel, the PCM modules. Each module has electric resistance on board. That electric resistance is there to serve as redundancy to the heat pump to perform when low ambient conditions are occurring, or if the heat pump water heater is in a fault. So we can rely on that electric resistance at those times. Each one of the modules has outfitted on it multi-purpose service valves. Those multi-purpose service valves are outfitted with a union, an isolation valve, and a hose bib. The hose bib's there so that we could flush the open loop side of the heat exchanger, providing easy service for a technician. What we're doing is that we're replacing all of the piping and fittings and headache associated with pairing a heat pump water heater with storage tanks that are piped in series that are also piped in series to a swing tank. We're just dropping a plug and heat unit in place in place of all of these components. And so to get back to those three selling points that I was talking about, reduced footprint, quicker install, and reduced complexity, we chose to model this out in a side-by-side a couple of mechanical rooms. So what you're taking a look at here on the left-hand side is a mechanical room that has two Medusas in it, our mixing and monitoring station that we're also offering, I'll touch on later. And then over to the right-hand side, you're seeing an equally sized system. So 180,000 nominal BTUs, 750 gallons of storage, swing tanks, expansion tank, all of the piping, etc. What we did was we got the bill of materials that's going to be required to pipe both of these systems. And it's obvious and evident here that the amount of time to install this goes from probably days down to a day. It's 80% less anchoring points, 65% less pieces of cut pipe made out in the field, 75% less fittings and valves. And quite frankly, the room over to the right, you couldn't install it like that anyway. There's no service clearances.
Austin, we're not seeing the picture you're describing.
All right, have you been able to see any of the pictures that I've been talking about?
No, I can see them.
I'm able to see it. John,
No, I just see the mixing stations.
Oh, it looks like you jumped ahead of me, John.
Yeah, you can go back, John. If you ever get ahead, you can scroll ahead with your slides, but you can always say return to presenter. Yeah.
Yeah. All right. So as I was saying, the room over to the right, you couldn't install it in that way. The heat pumps don't have the proper clearances. The tanks don't have proper clearances, et cetera. You would need at least a 50% larger room for this. So while the Medusa, the Pyroclast is a great option for new construction, it's also an equally great option for retrofit, where the mechanical rooms were designed to work around smaller gas-fired appliances. It addresses quite a bit of needs, and it also reduces just the risk of errors, leaks, and inefficiency that oftentimes are present in heat pump water heating systems, not because the technology doesn't work, not because the contractor's, a poor contractor, just the amount of stuff that can go wrong from the point of design to the distributor to the contractor. We're just trying to minimize all of that so we could all be successful. So this mechanical room, this is a piping and instrumentation diagram here of a single Medusa system that comes with our mixing and monitoring station. Just putting this out there so you could visualize even better what is, how you would actually pipe one of these. This next piping and instrumentation diagram is a little bit better of a depiction of what that previous mechanical room looked like with two Medusas inside of there. This one doesn't show the mixing and monitoring station, but I like it because it's just demonstrating that we are running the system as a return to primary. So, what is inside setup that you could see right up at the top of this picture. These are the clearances, dimensions, and connections associated with the unit. So as far as clearances go, we share all of the same clearances that are associated with the Nile C90 heat pump. We've put our electric control panel out to the front. Similar position that the Nile C90 has. We have same 24-inch clearance out the back, 24-inch clearances off to the sides. That small 38-inch clearance to the left has to do with the electric resistive rods that are embedded in the evaporator coil of the C90. So in the rare event those fail, you need that little 38-inch clearance to pull those rigid rods out. The dimensions of the unit are 38 inches by 88 inches by 96 inches tall. So it's quite a slim package when you consider the fact that you're getting all of this on board in, 92 square feet or so. The couple of connections that we have 4. There's hot out, cold in, and a small 1/2-inch line for makeup water. That makeup water is there to for the closed loop side of the system. The heat pump is in a closed loop between itself and the batteries, and the batteries also have another side, for the open loop to suit the open loop side of the building. We also have a 1-inch connection for condensate. So the last thing I want to mention about the product before I move on is we are coming in at about 4,800 pounds. If you were to do the math on what 375 gallons of water weighs, you would arrive at 3,149 pounds. That would not be taken into consideration the weight of the steel, the insulation, a heat pump, controls, piping, etc. So we are quite light, which also mitigates some structural concerns that have existed with the heat pump water heaters. Without further ado, I'll move on from here. This is our mixing station. We offer this not just for return to primary systems, not just for Medusa systems, but also multi-pass systems. And we have another configuration for single pass systems with swing tanks, etc. The swing tank in single pass one looks very similar to the one up here on the screen. The one on the screen is our return to primary one. This is the only mixing station that is on the market that features energy metering and remote monitoring capabilities. So earlier in this discussion, when we were hearing about the hot water forum and all you guys wanting M&V, while I would love to sell these only with Nile water heating systems, heat pumps or Medusa, whatever, you could use this to gain an insight to the system that you're taking a look at, whether it's a retrofit project or you've got another heat pump system going on, that you want to know what kind of hot water usage that building is doing, and you want to be able to observe that remotely, adjust the set point of your mixing valve remotely, etc. We can do that for you. This is a prepackaged swing tank. One thing I've heard from this community is that swing tanks, if they are not outfitted with a balancing valve, can operate 5 to 6 times more than they were designed to. So by pre-packaging this swing tank and having an outdoor rated offering that's pre-piped, this is the only one I'm aware of that's on the market. We're addressing a couple of needs here, just further reducing complexity, further reducing risk. If a plumber just wants to make the piping between a couple of tanks and then run it over to here, this is all the confusing stuff that oftentimes gets messed up. So we're just hitting the need there. If you don't want to use this as a swing tank, you could also use it as a standalone electric water heater as well. This is a brief little update of something else that we've got going on that's kind of innovative. We did participate in a CalNext grant in 2024. It was largely modeling focused. We conducted a CFD with Roush Performance for our atmospheric return to primary skid design. The CFD and modeling was quite informative, and it resulted in making a couple of design changes. We're going to be deploying 2 of these packages this year, about June, July timeframe as well. And we're excited to see how that goes. So thanks to AESC board, I'd recommend reaching out to Valmiki. Shapes and sizes, like I mentioned. So we know that not.
Hey, Austin, I don't know if it's just me, but your audio keeps coming in and out a little bit, or just here at the end.
Yeah, sorry about that. Some rain started.
Oh.
Yeah, is this a little bit better?
Yeah.
All right. So we understand that all buildings are not, they perform different. They're large, et cetera. We can do skids for single pass, multi-pass, combination, electric and gas, you name it. We're here to help with anybody, whether it be a developer, whether it be one of you guys on the call, whether it be a contractor looking to address a single job. We're happy to help. And that's all I have for you guys. I've got one last slide here. If anything that I said today is interesting to you, you're looking to work together, collaborate on something, you can reach out to me directly at austin@htecompany.com. If you're interested in a Pyroclast product and you're not in Northern California, please reach out to Nile Water Heating Systems, or you can reach out to us if you are in Northern California. So thank you guys for the time today.
Thank you all for your fantastic presentation. I'm going to stop sharing a screen and make sure we're all visible. Great. So I guess first question for you all that folks might be really interested in are, when and where are your products? Are these new exciting products going to be available? So why don't we start, Greg? Why don't you start with you, and then we'll go Austin, then Dan.
We're looking at the end of second quarter, first to third quarter, and it'll be through all of our normal distributors across the country that sell wholesale.
Okay, that's great. Thanks so much. Over to you, Austin. You said a little bit in your presentation, but yeah, highlight that a little bit.
Yeah, we are taking orders right now. They are available for order. You can get them through Nile Water Heating Systems distribution around the country. So the reps that rep Nile, or if you're Northern California, you'd come to us.
Okay, and the first installations I think you mentioned are the first products being shipped this summer. Is that what you had mentioned?
Yep, the first 9 are going out the door, and then we expect another 10 or so to close before September.
Great, and then over to you, Dan.
Yeah, thank you. So ours should be available commercially here as we hit Q2 as well. So we're getting ready to ramp up and get into production right now. So it's we build, we stock, and then we've got them available. Where you can find them is, we also deal in the wholesale channel, so you can find them there. We've also got other areas that you have access as well, some of our retail partners too.
Great. And folks, feel free, if you want to ask a question to all or one of our panelists, feel free to raise your hand or put your questions in the chat. Jeff is he's talking about I think a little bit at the demand response and being able to talk to us about each of your products with demand response and whether they're able to heat, water hotter for times and then coast through those peak loads to make use of lower electric rates. So Austin, why don't we start with you first, and then Dan, then Greg.
Yep, certainly. So we are more than capable of doing that. That could all be done remotely. We could explore it case by case. We're not releasing it right now with the ability to, what I'm trying to say here is that in California, we have time of use from 4 to 9. Load shifting beyond that, sure, we could. But if you want to look at it from a case by case basis, we can do that. We're not, if you wanted CTA 2045, we could put it on there. It's but from my understanding right now, after listening to these calls for several years, it doesn't appear as though there's much going on with forcing demand response. But we stand ready to, put it on there if needed.
Okay. Dan, over to you.
Yeah, from a GE perspective, we've got options when it comes to demand response. One easy option is we've got a time of use feature built into the app. It's a very simple way to operate it. You simply put in your zip code, select your utility provider, select the plan that you're on, and it downloads directly into the water heater itself. The other option, obviously, we've got the CTA module on our product, so you can have control that way. And there's also direct communication that's available as well through our Smart HQ for utility companies and those sort of things. So we got a variety of options around that. Hopefully, everybody kind of picked up on the importance of the mixing valve that we've got in there, that you could actually load this water heater up to have excess capacity in those off-peak time periods, so that during peak periods, the water heater never even has to turn on to even try to catch up with anything. So
I continue to be a little amazed that this question always does come up, because heat pump water heaters only use about 550 watts of power when they run. So load shedding doesn't have a whole lot of impact on the grid when you're turning off the highest efficient product that's in the entire house. And then you take into account the question of everybody wants to load them up. And I'm thinking, let's see, they put mixing valves on them in California, Vermont, and other states. And every contractor that has a mixing valve on it, what does he do? He cranks it all the way up to 140 degrees. So where do you go for load up from there on most of the products that are in this industry? That opportunity, again, is about this big. So yes, can you load control mine? Absolutely. It's CTA 2045, JA 13, but that really shouldn't be the focus of where we go. The focus should still be to get, a few million of these products in American homes, and watch what that does to the grid, because chasing this thing just doesn't always make sense.
That's good cautionary tale there, Greg, especially with those mechanical mixing valves and cranking them up. Gary Klein is bringing up a good point here, just the need for access to maintenance and service, if there is one. I know y'all have been highlighting this, but let's just spend a moment chatting about it. Talk to us about how your product helps assist with this, with a challenge that's been recognized and being able to maintain these in the field. I know you all have said a little bit, but speak a little bit more in depth. How can you maintain your product when there's any sort of problem in the field? And Greg, we'll start with you on this one.
We're open 24/7. We teach contractors to call us even before they go out. We teach them to use our For the Pro app on their phone to be able to get assistance directly from that if they need to watch something before they go through the training material again. But we literally walk them through and provide the parts. So it makes it very easy for us to stay in touch with that plumbing professional.
Great. Yeah, thanks. And let's go to Austin. Let's go to you next.
Yep, certainly. So by decoupling the heat pump from the thermal batteries on our system, we are thereby protecting the heat pump from a lot of errors that occur, scaling and fouling of the condenser within the heat pump. And that way, we have exposed to the open loop side the batteries themselves. That's why we've gone ahead and we've fixed those multi-purpose service valves to each one of the connection points of the batteries, so that you could easily flush the open loop side. The water quality across California, and I'm sure, of course, the rest of the United States, varies from region to region. The maintenance that we would encourage, along with regular maintenance of the heat pump water heater, would be to just flush the open loop side to reduce any risk of scaling or fouling on the open loop side.
Great, Dan.
From a GE side, we've built our product with serviceability in mind, right? Whether you're talking about the refrigerant system or you're talking about, tracking things down from, let's say there is a fault code that happens, we display that on the product, we display that on the app. It's all about that open communication on what it is that you need to service. And similar to what Greg was saying with our products, we've got that capability with that Smart HQ app that we could connect into the product and see and understand what's going on with the unit itself. So we've got all those different capabilities. Even with, and I'm glad Austin brought up the water conditions, right? And that's, none of us can control the water conditions wherever you're at, but we've also got some technology built into our mixing valve so that we prevent buildup on the sealed surfaces inside that mixing valve, because we know that's a pain point with the aftermarket mixing valves out there today.
So as we're closing down our session, talk to us about, and Dan, we'll start with you on this one. We've heard this in various ways throughout each of your great presentations. We're 15 years into the heat pump water heater, heat pump water heater's history, and there have been some pain points, and each of your products is trying to address those pain points. So maybe pick out 2 pain points that your product has responded to. And so Dan, why don't we start with you? What were the top 2 pain points that y'all wanted to address when designing this new GeoSpring?
Yeah, probably top of the list is got to be the 120 volt convertibility. And look, we know the 120 volt is not, big demand at this point, but it's the next push. So we wanted to make sure that when we came out with our 120 volt, that we had a good experience, right? None of us want those products to give a bad experience to any installer that's out there. So having that option to convert that to 240 is really a key thing, because you avoid those kind of issues if there's a problem with perceived capacity of, the 120 volt keeping up with things out there, right? The other thing is the serviceability side. That's probably my top two, just because, service is key of mine. We want to make sure that you put a product in and it stays in the home for a long time, whether it needs work or not need work. So it's probably my top two.
Great. Austin, how about over to you?
Yep. There was a study done at the PG&E San Ramon lab that exposed that return to primary systems were the most efficient central heat pump water heating systems that you could do for a commercial setting. And also taking a look at the various, how a system COP tanks when you go and include a swing tank, because you're maintaining your recirc losses with electric resistance rather than a heat pump. We wanted to bring a product to market that not only addressed the new construction, but also the existing building stock that is all over the place. What the retrofitting a building with heat pump water heaters, while it's possible, it's quite a pain. We wanted to reduce complexity, decrease install time, and reduce footprint, and that's the inspiration for the product.
Fantastic. And Greg, how about you?
Well, obviously, we had some ground to make up when it comes to our efficiency. Our UEFs were the bottom of the industry at that point, still very respectable. And we leapt ahead of everybody except Dan at GE. He had to pop my bubble at AHR. So, yeah, that's okay. I still tip my hat to you for that, brother. But being able to increase the efficiency, just really was a big jump for us to be able to do that. Also trying to, again, make it available with all of the air exchanges taking place on top. I understand the complexities of not having that in the top and having to twist and turn and bounce air and do things with a rear exhaust system that I've dealt with for many, many years. And as a result of moving things to the top, we've simplified that installation. The electronics as well, making this very simple for a contractor, for a homeowner to be able to navigate, because everything that I've seen with my 15 years of doing this is simple is what sells, and it's what contractors appreciate. If they can't figure it out, we know they don't read books. If they can't figure it out punching a couple of buttons, they get frustrated. So we think we've really hit the nail on the head with this.
Thanks. That's great. Well, thanks for those great responses. Thank you, all three of you, for those fantastic answers. There's a couple other comments in the chat if y'all could look at those, but we'll have to leave it here because we are coming up on time. Let me just load our slides here for the final couple takeaways, and then we'll let you all go. But yeah, so it's huge thanks to Greg, to Dan, and to Austin for being on today. Check out these products. They're really exciting. We'll send out all slides and recording afterwards. And of course, join us at the advancedwaterheatinginitiative.org. See which working group you'd like to be part of and how you want to get engaged in market transformation. Thanks so much, Greg, Dan, Austin, everybody for being here. We'll catch y'all at the next one.
Thank you, Joe. Thanks, everyone.